Okay, have a look at the effect on what enlarging shape has on the area and the volume as well as the lengths. So let's just imagine what happens if I times all the lengths in this shape by a scale factor of 2. So the height is going to double, the width is going to double, and the length is going to double. So let's just draw our sketch of this shape. Not quite as good as the Google SketchUp version that I've drawn. Okay, just get a little rubber just to tidy it up slightly. Okay, here we go, we've got this shape. So now the height is 2 meters here instead of 1 meter there. It's 4 meters wide and it's 3 meters. It was 3 meters long, so it's now going to be 6 meters long. Now in this one, the surface area here along this side, okay, was 1 by 2. So the area there was 1 times 2, which equals 2 meters squared. Now the new surface area over here is now 2 times 4, which is equal to 8 meters squared. So where the lengths have doubled, if we notice what's happened to the area is now times by 4 from 2 to 8. Let's just check if that's consistent all the way around. So let's look at this area on this side and compare it to the area on this side. So here the area, okay, is 2 times 3, which equals 6, and on this side it's now going to be, sorry, it's not 2 times 3, sorry, it's 1 times 3. Let's just rub that out. It's 1 times 3, which is 3. Okay, on this side it is 2 times 6, that's too high, 6 long, which gives us 12. And again, 3 into 12 goes 4 times bigger. And let's just check with another measurement, which is not 1 times something. If we do this side, this face here, okay, this is 2 long by 3 long that way, so it's 2 times 3, and that equals 6. Whereas this side, we've got 4 times by 6, which is 24. Again, 4 times bigger. So all the way around, the areas are increased by a factor of 4. What about the volume? Well, the volume of the small cube equals 1 times 3, 2 times 3, which equals 6. And of the large cube, well, not cuboid, sorry, and of the large cuboid, it's equal to 2 times 4 times 6, which equals 8 times 6, which is 48. So we have a much bigger increase here. 6 goes into 48 8 times. Now what you will notice is this has been increased by a factor of 2, this has been increased by a factor of 2, and this length increased by a factor of 2. So the overall increase is a 2 times 2 times 2 factor, which is actually 2 cubed. So the volume scale factor equals 2 cubed. So we can see that the volume has gone up by a factor of 2 cubed, which is equal to 8. Here, if we look at the area, each of the lengths were doubled. So it's a 2 times 2, which is equal to 2 squared. So the area scale factor was equal to 2 squared, which gave us 4. So therefore, if we triple our lengths, okay, if we triple our lengths, so if we say the linear scale factor, length scale factor equals 3, the area scale factor, to work out any area, we'll have to do one length will be times by 3 and the other length will be times by 3, and that will give us 9. So the area scale factor is the length scale factor squared, and the volume scale factor, okay, the one length will be times by 3, the next length will be times by 3, and the next length will be times by 3, which will give you a volume scale factor of 27, i.e. we cubed the length scale factor to get the volume scale factor. Now how can we find a relationship between the area scale factor and the volume scale factor? Well, always bring it back to length scale factor. If you know the volume scale factor, so say for example the volume scale factor was equal to 64, say. We want to get that to the length scale factor. Well, we know the length scale factor cubed gives the volume scale factor, so therefore cube root the volume scale factor to get the length scale factor, and that will just give us 4. And then to find the area scale factor, we can just do 4 squared, which equals 16. Okay, so therefore, say we have an example. We've got a cone. All right, we know that the volume equals, I don't know, say 6 centimeters cubed, and we have another volume. Okay, where we know that the volume of this one, all right, is equal to 48 centimeters cubed. So we can see the volume scale factor, 6 into 48 is equal to 8. So if we are told the area, the surface area of this one, total surface area happens to be 15 centimeters squared, we can now find out the area scale factor. We cube root this to get the length scale factor, which gives us 2, and then we square this to get the area scale factor, which is 4. So therefore, we don't know the area of this, but we can find the surface area by timesing the old one by 15. So the area will equal 15 times by 4, which is 60 centimeters squared. I hope that gives you an idea of the relationship between volume scale factor, length scale factor, and area scale factor.